EIGRP has a far more sophisticated metric than any other IGP, and we can see that here. The components are really bandwidth, delay, reliability, and load, and MTU. With that said, they're not all used to provide us a number for the metric. What are used? By default, we have bandwidth and delay. And then we can turn on reliability and load if we want to, but we don't want to because they cause massive instabilities because load changes based on how many packets are going through. Well, what if you have a loaded link and then you see an unloaded link and you move to that unloaded link because it's got a lower metric, and then it later becomes loaded again because you're using it now? That's a very dangerous thing. Those attributes, those metric components, by the way, are turned on and controlled, again, by K values. I'll show you how this is done. And then finally, we have an MTU, which is just a tie break. It's not going to set a value, but it is a tie break to say, hey, this pathway has a larger MTU. All things being equal, that might be a better path. So what we do is this. We take the bandwidth and the delay components by default, add them together, and then multiply by 256. And the reason why is because EIGRP's predecessor of IGRP had a 24-bit metric, whereas EIGRP has a 32-bit metric. And they wanted to convert the two. They wanted them to be compatible. So what they did is they said, I'm just going to multiply by 8 bits, all set to 1. I'm going to do an 8-bit shift, which is 256. Okay, but merely saying that these are added together, that's not enough. Because the bandwidth is the minimum bandwidth along the pathway. We would call this the weakest link bandwidth. Let me show you how this would work. Let's say I have a pathway between some routers, and I'll drop in a few routers here to illustrate my point. I could have a number of different speeds interconnecting these devices. And let's say I got a 10 megs, maybe I have 100 megs, and then I have a T1, which is 1.544 megabits per second. In that case, what is the input for the bandwidth parameter? It'd be 10 to the 7th, which is 10 million, divided by the minimum bandwidth, which is the T1 speed. It doesn't even consider the 100 meg or the 10 meg ports. Why? It's because it's the weakest link bandwidth. But the problem is we need to add something up. We need to accumulate something, because this would be treated the same as another pathway, which might have been a lot shorter. What if we're getting there through the same sort of links, but we get there much, much faster? We only have another one extra hop. We need something that's going to be a tiebreaker. And so how do we do the tiebreaker? Well, we add up the delay component. The delay component is a summed value. So each of these interfaces on the routers has a delay. And we can see this value here, but let's go to some equipment. So if I were to look at just the raw layer 2 interface information, I can see all of these values: MTU, bandwidth, delay, and also reliability and load, which are values out of 255. So those are really 8-bit values, are they not? Delay is in tens of microseconds. Now, wait a minute. This says U seconds. U seconds. What is U seconds? Well, that is short for the mu symbol. I tried to draw the mu symbol. It's a Greek symbol. And it looks a little like what I've drawn. The closest character that they have is a U. So that is a micron, or a microsecond, if you will. So 10 microseconds, still really, really small. Okay, 10 1/millionths of the second. So that is taken as an input of, in fact, really 1, because the delay is in tens of microseconds. So if we have 10 microseconds, or in this case 100, we just divide by 10. And that's the value that we see input and told to the EIGRP metric calculation. So again, we take the weakest link bandwidth, sum the delays, and that's the default behavior. If we did want to control this, we can manipulate those K values. How do we do that? And are there gotchas? Oh, we can, and there are. So we first can see these K values with the show IP protocols command. These are the defaults, 1, 0, 1, 0, 0. Now these have to match for neighborship to form. So if I change these, now I begin the input of these values. So if I change these, it will break adjacencies. And I'll have to do this on all the routers for me to be able to make this work. It's not a good thing. It has to match for all the routers in your autonomous system. But what I did is I just doubly weighted bandwidth, which is the first of those values, the first of the 5. And look at all those messages. That's not looking pretty. So I'll just undo my work. And actually, let's quickly do a show IP EIGRP neighbor. No neighbors. Bring it back. We'll reform our neighbors. Things will be back up and running. So be very careful with some of these elements of EIGRP that we're training you about. Just because now you understand more about the K values should not imply that you want to touch these.